tumble and fall down hills. Potential energy is the storage of energy in a system like the one I've set up here. Potential energy is the energy stored due to the height of an object falling. This is because the higher up an object is, the longer it has to fall, and the longer gravity can act on the object, making it accelerate faster and faster. Now, it doesn't keep its potential energy because this energy is stored and not put to motion. But the energy is then transferred into kinetic energy, which is the energy of something in motion. Kinetic energy is calculated by how fast the object is moving and how heavy the object is. So at the top of the roller coaster, when something's like this, it has the most potential energy possible in the system because it is at the highest point that the track will allow. But as it rolls down here faster and faster and faster, when it sits at the bottom, it has the most kinetic energy because all of the potential energy stored from up here has now transferred into speed, moving the cars forward. Now on the other side, as it goes uphill, the energy from the kinetic energy is now being transferred back into potential energy because it will go back uphill like this and then gain height, meaning as it rolls back down, gravity can act on it longer. Just like that. But as we saw, the cars didn't go as high as when I dropped it. Why is this so if all the potential energy is then transferred into kinetic energy? Well, the answer is, in a system and in real life, it isn't. Due to something called friction. Now, the friction in this system is caused by the plastic wheels rolling on this urethane track. The friction in this system is very low, but because the cars are so light, it has a drastically large effect. Now, friction is not something, it acts like the cars are being pulled back on. So if I was running and somebody grabbed the back of my shirt and pulled, that's what friction inherently feels like. But in the system, friction is then converted into heat. So some of the energy that is stored way up here, most of it is put into speed, but a very small amount of it is turned into friction, which is then turned into heat. Meaning that when it comes back to the other side, it has lost some of its potential energy, so it cannot go up as high on the other side. Now that I've talked about the difference between kinetic and potential energy, let's do some calculations so we can mathematically see the difference between the two. Before we start using any of our calculations, I needed to find the speed in which the roller coaster cars are moving. I did this by recording this video in slow motion and seeing the speed in which the roller coaster cars are moving past the 2-inch strip of tape. I did this by recording the frame rate of the camera and then recorded how many frames the roller coaster car was in front of this piece of tape. I could then use the distance of the tape and how long it was in front of the tape to calculate its speed. Now that we've found the velocity of the roller coaster cars, we can now use the two different type of energy equations to find the energy of the roller coaster cars at the given moments. So, I needed to record a couple different measurements. The height in which the roller coaster cars were dropped at, which is 0.53 meters. The mass of the roller coaster cars in kilograms, which I measured this by using a gram scale, which measured the cars to be 34 grams, which converts to 0.034 kilograms. I then needed the acceleration of gravity, which is how fast gravity will pull an object down towards the Earth, which is 9.81 meters per second squared, and then using our velocity of 1.524 meters per second, I can now calculate the amount of energy at the two different spots on our roller coaster. So to calculate our potential energy, as you can see, like I said before, this equation is not dependent on how fast the roller coaster cars are moving. This is because when you're holding something up in the air, it still has that stored amount of energy. So this equation solely relies on the mass and the height in which your object is placed at. So when I plug this in to the equation, it turns into our 0.034 kilograms times 9.8 meters per second squared, the acceleration due to gravity, times the 0.53 meters in which the roller coaster cars were dropped at. and that turns into 0.1767 joules of energy. Now for our kinetic energy, this type of energy is defined by how fast an object is moving and its weight. Now the equation for this looks like 1/2 times the mass times its speed or velocity squared. So when I plug in our numbers, that looks like 1/2 times 0.034 kilograms times our 1.52 meters per second velocity squared, which now turns into 0.0395 joules of energy. So like I said before, some of our potential energy is lost due to friction. And as you can see by the two different calculations, our potential energy is almost 3 times greater than our kinetic energy, meaning we lost 2/3 of our potential energy to friction, which then turns into heat. Alright, so in summary, we learned the difference between kinetic and potential energy, with potential energy being the storage of energy within an object in a system, and kinetic energy being the moving energy of an object in a system. We also learned that we can lose potential energy due to friction, which converts that energy into heat or light. Thank you for watching this week's video, and stay tuned next week for another one.